So today we are diving deep into one of the biggest, baddest mysteries in all of physics, the black hole. But we're going to look at it through a wild new lens, one that turns black holes from these universe-ending monsters into, well, into something a whole lot weirder and way more like a computer.
I want you to just forget everything you've seen in sci-fi movies. You know, that idea of an infinitely tiny, infinitely dense point where all the laws of physics just give up and break down? What if that's all wrong? What if the singularity just isn't there? The reality could be so much stranger and honestly, a lot cooler.
Okay, to really get why this matters, we have to visit what is basically a cosmic crime scene. It's called the black hole information paradox. And for about 50 years, it's been this massive headache for physicists because it puts their two favorite theories into a cage match.
So here's the problem in a nutshell. You've got quantum mechanics, right? It's like the fundamental rule book for reality. And it says, rule number 1, information can't be deleted, ever. It can get scrambled, hidden, whatever, but it's never truly gone. But then you have Einstein's relativity, which gives us black holes, which look a whole lot like giant cosmic paper shredders. See the problem? One of them has to be wrong.
And look, this isn't just some small academic debate. This is a full-blown contradiction right at the heart of how we understand the universe. It's a flashing neon sign telling us that a huge, crucial piece of the puzzle is missing.
So how do we fix it? Well, the theory we're digging into today says we have to completely rethink what reality is, right down at the tiniest level. We need to stop thinking of space-time as this smooth, continuous sheet and start seeing it more like a super high-res digital screen.
And that's the core concept right there. Discrete spacetime, the idea that the universe is, for lack of a better word, pixelated. It's built from these unbelievably tiny, fundamental units. You can't just keep zooming in forever. Eventually, you hit the bedrock. You hit the base resolution of reality itself. And this is where it gets really fun and kind of cute. These little pixels of reality, they're called S-units. You can picture them as these tiny, adorable little processors. And all they do, all day long, is pass around these little packets of data called tokens. Literally everything that happens in the universe is just this gigantic cosmic game of catch.
The rules of this game are actually pretty simple. 1, reality is just a massive grid of these S-units. 2, everything that happens, a star exploding, you drinking your coffee, it's all just tokens being passed from one S-unit to the next. And 3, space-time isn't some pre-existing thing, it's the result. It's the pattern that emerges from all these little trades.
Okay, so now that we have this new, pixelated, token-passing view of the universe, let's go back to our main culprit. In this kind of world, what even is a black hole?
And here is the big reveal. The event horizon, it's not some one-way door to oblivion, it's a traffic jam, an ultimate cosmic gridlock. It's a region of space where every single one of those tiny S-unit processors is completely 100% maxed out, processing the absolute maximum number of tokens it possibly can.
So a black hole isn't this dead, static thing. It's a token storm. It is the most dynamic, the most active, the most computationally intense place in the entire cosmos. It's not frozen. It's a zone of constant, frantic, maximum activity.
This changes everything about how we see them. That scary singularity at the center? Nope, it's a saturation region. The idea that time stops? Nah, the updates just keep happening over and over inside. And most important, information isn't lost. It's just trapped by the insane traffic.
Honestly, this is the perfect analogy. We've been thinking of a black hole like a crashed computer, the blue screen of death for physics. This theory says, no, no, no. A black hole is a supercomputer with its CPU pegged at 100% utilization, just churning through an unbelievable amount of data.
So the event horizon isn't a shredder, it's a bandwidth firewall. Information can't get out, not because it was destroyed, but because there is literally zero available bandwidth for an outgoing message. Every single channel is busy.
But wait, this brings up a new question, right? If the info is just trapped, not destroyed, how does a black hole evaporate? How does that information ever get out, which is something we know has to happen thanks to Stephen Hawking?
The way it escapes is just beautiful. Every so often, completely at random, one of those little processors right on the edge of the traffic jam fluctuates. Its workload dips for just an instant, from 100% down to, say, 99.9%. And in that tiny moment, a little channel opens up. A packet of tokens, a piece of information, manages to sneak out.
And that slow, steady trickle of information packets escaping from the edge of the storm, that is Hawking radiation. It's not some weird magic happening in empty space. It's the natural result of a maxed-out computer occasionally freeing up just enough bandwidth to send a tiny packet of data.
And here it is. This is the solution to the whole paradox. The radiation isn't just random noise. Because the way those little packets escape depends on the chaos happening inside the black hole, the stream of radiation has subtle patterns in it. The sequence, the timing, it all contains correlations. And those correlations are the original information, just scrambled and re-encoded. It was never lost, it was just throttled.
So let's just zoom out for a second. If this whole theory is right, what does it mean for everything? The implications are kind of huge.
The bottom line is simple, and it's absolute. Information loss is impossible. The rules of quantum mechanics win the day. The paradox that has tormented physics for half a century, it just dissolves.
It turns out we were just making a category error. We were asking the wrong questions because we assumed there was a place where physics just crashes. But maybe there aren't any places like that. Maybe the universe never truly breaks. It just has finite parts that can, under really extreme stress, get completely saturated.
And that leaves us with one last absolutely mind-bending thought to chew on. If the most extreme, most violent objects in the cosmos are really just computers running at their absolute physical limit, then what kind of program is the rest of the universe running?